Alright, let's take a look now at the base catalyzed esterification of an acid anhydride. We're going to be using an asymmetric acid anhydride here, reacting with an asymmetric reagent. So we're going to be ending up with 4 different products here. Let's take a look at the mechanism. And again, you'll see that this is following the classic negative mechanism that we've been discussing. And we can see that if we attack this C double bond O first, that this will end up being the Y group. You can see that the X group will end up being this. So that would turn out to be X negative right there. So there's your X group there. And this would be your Y minus, which will be turned into YH by the second step, H plus. So initially it would be Y negative, but then we'll turn into YH. And you can see how that's going to work out. Alright, then we can use the other attack on the other C double bond O, that will give us our other set of products. So let's take a look at the mechanism. Now remember, when you're given a choice of 2 reagents here, you'll always take the one that's negatively charged because that's going to be the less stable one, and that's the one you'll react first. Right, so we'll attack the left side first. And you can see that the electrons will jump up on the oxygen, like we've already seen before. And then the negative comes down, kicks out the leaving group, and the leaving group is always the Y group. Right, that gives us our ester, and then we've got our negatively charged Y group coming off, and then we can use our second step H plus to create our carboxylic acid. Now if you think back to the base catalyzed hydrolysis reaction, that is where we used H2O to attack the acid anhydride. What happened was at some point we formed a carboxylic acid in a basic solution, and we ended up having a bit of complication there. We had to deprotonate the carboxylic acid. In this instance, we don't get any of that occurring, and the reason for that is because we never form a carboxylic acid in a basic solution. All we ever form is an ester, and that's not subject to the kinds of reactions that we saw in the hydrolysis process. So you don't have to worry about any of that. We do end up adding H plus in a second step, but that's not what I'm talking about. I'm talking about a carboxylic acid formed in a basic solution, and that never happens here. Alright, so that's how we get our first set of products. Let's take a look at the second set. So again, the O negative comes in, kicks out, kicks the electrons up to the O, forms another O negative. And then the electrons will come down and kick out this. And that gives us our second ester. And then we can add H plus, and we end up getting our other carboxylic acid product.